Hi, everybody. Welcome to another Couchbase webcast. We are joined today by Laurent Dugan, Director of DevRel, and Matthew Groves, DevRel Engineer from Couchbase. We had a great session last month on JSON data modeling. Today, we're going to look at data modeling in practice and what that looks like in the real world. We're going to get kind of an overview of Conduit, which is an app that's been created in-house here at Couchbase, and just look at some really great, specifications for what you need with any kind of data modeling, taking a tour, talking about maybe some of our new AI developments that are in progress. And so we are also joined today with a crew from LinkedIn. We're streaming out live to LinkedIn right now. So hi, everybody. Please do use the chat function to chat with the other folks on the session. Use the Q&A to ask any questions throughout the session. And with that, I will turn it over to Laurent. Laurent.
Hey, hello. Good day, everyone. Thanks for joining us today. I am going to share my screen and fingers crossed everything should work because it worked yesterday. So hopefully you can all see slides. I think it works. Matt, can you? Yes. All right, let's go. Cool. So any question you have, please feel free to drop them in the chat. Please feel free to drop them in the chat on the webinar side of things on LinkedIn. We will try to answer them as we go. My name is Laurent Dugan, I'm the Director of Developer Relations. I'm joined with Matthew Groves, DevRel Engineer. And yes, today is JSON data modeling in practice. Last time we talked about the theory. I'm going to do let's see the agenda. I'm going to tell you what is Conduit, which is the app Suzanne told you about. We'll go through a little recap of what we talked about last month, 2 weeks ago, 3 weeks ago, last time. And then once we have that NoSQL recap, we'll go through the Conduit domain model and how we can do the data modeling for a NoSQL database, for instance, Couchbase. Some advice might work for other NoSQL database. We'll try to stay as generic as possible, but of course, all the example will be done with Couchbase. Then we'll have a quick demo. I'll try to show you a bit of live code. Not live code. I'll try to show you code live, which is different because no one wants to know how I'm typing on my keyboard. And then, yeah, a little summary, a little Q&A, and off we go. All right. So what is Conduit? It's a real-world project. It's all about building a proper, I guess, first application that means something. We're all building to-do apps. To-do apps are a good example. There's a little bit of state, there's a little bit of front end involved. It's a good starting point to showcase some technology. Is it can we identify as a to-do list as a developer? Usually we develop some slightly more complicated things, and so Conduit is goal is to help you identify to something closer to your real life experience. So instead of a to-do list, we are going through a blog platform. It's a clone of medium.com and it's been already implemented into a variety of backend, frontend, and full stack solutions. Saying backend and frontend because it's not only a website, it's not only an implementation, it's also, and that's the most important part, a specification. You have an open API spec, you have a Postman test collection, so you make sure that your backend implementation works according to what they expected. It's also a front-end specification. You have the list of templates, you have a Bootstrap theme that's available. You can do end-to-end tests. They have end-to-end test scenarios, which you can see running on the right of the screen. Basically, they provide you everything you need to know to start your own Conduit application. So I'm going to move to this, which is an example of Conduit. You should see You should see a blog. You should see demo.realworld.io. This is the public demo. You can go there. You can try. You can sign up. You can sign in. And what you see here basically is the homepage, which is the feed, the articles, blogs that people have built. You can see on the right there's some tag. You can see a little icon to make your favorite article. So I'm going to click on that article. You can see the article have authors. They have tags. They can be edited. I can sign up if I want to. I can sign in as well. There's a bunch of things you can do. We don't have to go through everything in detail now, but basically it's available. You can try. It's fun. That's the app that we're going to clone, and those are the apps that people have done already. So if you go to front end, you'll see a variety of front-end implementation. Those two are very separate, and in theory, you can take any front-end implementation and you can map it with any back-end implementation. And if everybody's following the spec, it should work. It mostly does most of the time. I've tried a variety of things, and mostly worked. These are the currently maintained version of the front end. There are some unmaintained versions. There's also some planned version. So if you want to create your own, you can take a look. I know they have a list somewhere of what people are working on. So that's front end, that's back end. And if you search for Couchbase, well, there's the ASP.NET version that Matt did. You will also find an Express version that Naya Macklin did. You will find an Automan version and a Spring version, and soon, Scoop, there will be 2 more Python implementation using Couchbase, but of course you have it with every other databases, and you have full stack solutions. All right. So that was a very short tour of Conduit. It's a blog engine. If you know medium.com, you know what this is. I'm assuming that most of us are at least familiar with relational database management system modeling, which is using table and columns, and it's usually what you learn at school at the beginning. You have entities, they have different fields, they are linked to each other through relationship, which means you can model relationship, which is basically a key that's referenced on one document or one entity into another entity, which is the arrow that you see here. This is actually the I think it's a Postgres version that I took one of the backend implementation, because it's a SQL implementation. They already had a schema defined. You don't need a schema if you have a NoSQL database, but I thought, okay, let's go and have a look, and that's what the schema would look like if you were to build your own backend implementation using a SQL database. Okay, before we go into the specifics of Conduit for NoSQL data modeling, let's go through a quick recap of data modeling and NoSQL. At Couchbase, we store things in what we call buckets. Every buckets are subdivided into as many scopes as you want, and in each scopes you can have as many collections as you want. Why are we doing this? There's a variety of reasons we do that, but basically, if we provide you with a finer level of granularity, it means, well, first of all, it means you can map a structure to a relational database more easily. We used to only have a bucket, which was sort of, imagine you would store everything in S3 and you'd be done with it. It's kind of hard to, find exactly what you're looking for. So buckets, inside bucket scopes and collection. The more granularity you have, the better it is for your access control needs, for your security, your permissions. Not everybody needs to have read or write on this collection or this scope or this bucket. I'm only saying read or write because, again, in a NoSQL database, there's no schema. So you cannot have a fine-grained permission system as you would with SQL. This is usually moved in the application layer. It also helps for the query and index performances, because if you build an index for the whole entirety of your bucket, it means that this index will go through every field of every document, but usually an index, it's only about 1, 2, maybe 3 or 4 fields. So it's not like super efficient. So you want to have a smaller granularity, so you have smaller indexes, which is great for a variety of reasons. It's going to be faster and it's going to be easier to replicate as well, because Couchbase, as most NoSQL data store, is a distributed database. So we need to sometimes replicate data because, in the cloud, when you're distributed, sometimes things go wrong. So you want to be sure you have a copy somewhere. So every data you have in Couchbase is replicated. It's the same for indexes. An interesting point as well about scopes, mostly, it's great for multi-tenancy. Let's say you have one cluster of Couchbase nodes, several applications. It's the same application, but it works the same for different customers. So if you have 10 customers, you have 10 scopes instead of having 10 clusters. It's much cheaper. You get all the security you need for a decent price. It's also great for replication. I've told you a little bit about this. When we replicate the index internally, but the cool stuff about Couchbase, it's one of the great things we're good at is synchronizing data across clusters or across the edge. And so we have a variety of customers that actually synchronize data from one cluster in a region in Europe to one cluster in a region in the US. And maybe you don't have to synchronize the whole bucket. Maybe you can just synchronize the scope you're looking for or the collection you're looking for. If we were to do a very naive mapping between a relational database and Couchbase, this is what you would get. A server database would be a Couchbase cluster. The equivalent of the database would be a bucket. The schema would be a scope. A table, which is where we usually reason in terms of data modeling, would be a collection. A table is usually what holds the schema of your data model. Here it compares to a collection. A row would compare to documents, and a primary key, which is the thing that people are using to build a relationship in SQL database, here is compared to a document key, which you have in every key value store. We're going to talk about how to properly design key in a NoSQL database because it's paramount for NoSQL data modeling. Speaking a little fast, do we have any question so far? Are we all good? No
questions coming in.
Telling us what they're using.
Or here yet. Nothing yet.
Hold on, something's weird. I'm not hearing you correctly, but I think that's my fault because you. Sorry, Matt, can you speak again?
Yes, sorry. So no questions yet on either the chat or in LinkedIn.
I have no idea why you are not going through my headphone right now, which is weird. Let's pretend that everything's okay, and let me move my headphones like this, and everything will be fine. All right. So, couple differences really. Two different data modeling approaches, whether you use RDBMS or whether you use NoSQL. Traditionally, when you use an RDBMS with table and columns and relationship, we strongly encourage you, and actually that's one of the things you learn at school, and it actually got me to learn that at work because you don't have to normalize everything. That's what we tell you at school. That's the most efficient way of using an RDBMS. You don't necessarily have to, but that's the promise. The promise is if you've normalized everything right, you should be able to query everything. Everything should be optimized. Everything should be consistent, which means because if everything is normalized, you don't duplicate data. So if you need to change something, you don't change it here and here and here and here. That's the promise of relational data model. The promise of a document data model, well, we don't have relationship. We don't have constraint. We cannot necessarily enforce by design a schema. So it's easier to have denormalized data, more natural, to embed data. We're going to talk more about this afterwards. But it also means that it's easier to change the model as you go. It's easier to scale. It's easier to be distributed. It's easier to be, basically it fixes a lot of problem we had in the cloud in 2009, 2010, where NoSQL was a thing. Is it still true anymore? I mean, not really. It's not, I mean, it's still true, but is it still only at DBMS can be normalized and only NoSQL should be vaguely normalized? Now every RDBMS does unstructured data, and not every, but most NoSQL allow you to do, to manage relationship, to do SQL, to do joins, which is some of the stuff that we do. So it's not as true as it used to be, but it's still a very good indicator on how you should model your data. And here we are on the two most important facts, this one and the next slide. The great question to ask yourself is, when do you embed data, when do you refer to data? Which goes back to when do you normalize and when you denormalize. Embedding data with your denormalizing it, you're copying it, which is great for reads because you only have to get the document you're interested in. You don't have to get the other referred document. Everything's there. It's fast. It's great for cache. It's great for speed. It's not great when you need to maintain consistency because, well, if you modify something here and it's copied in different places, you need to update those different places as well. So if you don't want to do that, you can refer to document, which is, go back to the normalization side of things. When you read something and you have references of this thing somewhere else, then you need to get them as well. It's great because you only need to modify it once because there's only one active version of the document that makes that holds the truth. But it's not great when you're reading a lot because then you need to read a variety of documents a lot. Now, one of the big difference, well, it's not a different question really, it's more of a, what can you do with Couchbase or with a SQL database? You have a key value API and you have a query API. At Couchbase, it happens to be SQL. Some of the database have other languages. And then key value. Key value is fast, but to do key value, you only get one value. You cannot get several documents unless you do several gets, which is not great. But at least it's fast. It's great to do create, read, update, delete operations. Some databases will let you get a subset of the document instead of the whole document. It's also easy to manage atomic operation, to have unique sets, to have counters, to have atomic counters. Most of those databases come from a caching background, so it's pretty easy to use a time to live. A time to live is the expiration of the document, so if you have a caching use case, that's great. And it's great for transaction because, again, you can be atomic easily, and you only modify one document at one point, at one time. The query API on the other end, if you want this to work, you need indexes. You need to work fast because a primary index is basically equivalent of a full scan, which means reading every document, going through all your data. So we don't necessarily encourage people to do primary indexes in production. And a secondary index is just indexing the thing that you need. So it's completely tailored to your query, which is supposed to make things much faster. You allow you to get more documents, allow you to select them, to also do any modification or deletion operation. We support joins, we support windowing function, command table expression. It should feel like 2024 SQL, I guess. But it feels like SQL that can manage JSON, which is the whole point. The main part, one of the main differences, one is going to be much faster than the other. With the data service, with the key value API, what you do is I have a key, I get the document, and I'm done. So it's basically just one network trip straight through the doc, If your database also have a caching layer integrated, then that's great because you just read the document in RAM, so it's even faster. That's great. That's what we do at Couchbase. But it's only one document, and you need to know the ID first. If you do a query, well, our query service is like a REST API, so it's stateless. You can have as many query services as you want. But once you send a query, the query service will parse the query, get the query plan. So you need a bit of CPU to get that going. It will, once it has the query plan, go and fetch your data, ask the different index service. If you have a covering index, which is an index that has all the data you need, that's great. If not, it will go to the data service and ask for the rest of the data. It's also integrated with our search service, which is our full text search capabilities. So it's kind of the same story. And then it will gather everything, create your projection, which is basically your select clause, map that, and then send it back to you. It took me much longer to explain this to you than to explain key value to you. And that's a very good reason. It's slower, it's more expensive, but it can do so much more. So those are the main thing to know when designing for NoSQL. Now, if there's no question, we can go through the actual.
Well, just one little question here. So there was a question about some of the color coding in, I'm not sure which slide it was, one of the modeling slides. And the question was there any significance to the color coding? It might have been the poster slide, or it could be that slide right there. Yeah.
Oh yeah, because that I think that's completely doesn't mean anything really. What it can mean as a logical container is that you can have a different set of rights, a different set of permission. It can be used for different things. You can have different indexes. I don't want to say different schemas because, well, there's no schemas really. But one of the cool things you can do with Couchbase is you can infer a schema based on the sample of your document, which is quite nice. If you think about JSON, a JSON doc is just a self-holding table structure. A JSON doc has fields. Fields have types. They have names. So it looks a bit like a table. So you could have some sense of schema. But the thing is, well, they all have their own table. So it's completely flexible. But you can still get a sense of schema through a collection, and we encourage people to sort things like this.
Thank you.
Yes, that was the screen. Good. All right.
That's all the questions we have for now.
Okay. The conduit domain. Here's an article. If we look at the screen, as you can see, there's a title, there's a body, there seems to be an author, an article could be edited, deleted, there should be tags as well, there should be comments. So let's get a little more into the details. This is, on the screen, you'll see a split version of the OpenAPI specification that I've screenshot from a tool called Swagger. Swagger allows you to, well, basically parse an OpenAPI file and then allow you to see all the endpoints, all the schemas, almost the schemas, but all the object model that are attached to each endpoint, which is what you see here for the articles. For articles, you can get the full feed, which is what I had earlier. It was the home feed, so not necessarily all the articles that of the user I'm following, but all the latest article. You can get all the article from the user you're following, which means you can follow user, but more on that later. You can create an article, of course. You can edit it. You can delete it. You can get a single article because, well, you want to actually read the thing. And what you see on the right is 3 different objects, usually referred to as DTO, which is what the API is using, and not necessarily how you would model your data. This is the object that are moving on the wire through your API. And so the main one is the article, not new article, not update article, but the first one. So that's, I guess, it's easier to start with new article. It's just a title, a description, a body, and some tags. It's also the main thing you will be updating if you were to do I was going to say a post. It's a post to create stuff, put to edit stuff. You can see which one are mandatory, which is a good indication as well, with a red star. And if we look at the first one, the big one, article, there's a slug. And the slug is the, when you visit the website, it's medium.com/something-something-something. It's that part of the URL that refer to your blog. And if you look at the endpoints, the three at the bottom, you can see it's /article/brackets/slug. That means that slug is an important part of how you get data. Is this, should be the key? Let's talk about this. So we have the slug, we have title, description, body, tags. Tags are an array of strings. You get dates as a string format, and you get an author, which refer to another DTO, another object, which should also be an indication that maybe it should be either embedded or referred, but basically when you get an article, you also need to get the data of the author. So let's talk quickly about key design. Should we choose a deterministic key, a deterministic ID? Deterministic meaning, should it be completely random? That's not deterministic. Or should you, as a user, be able to know what it is? In our case, there's a couple of things we need to talk about. Most articles are fetched when you have several, are fetched through a paginated list with filters. Are you getting the 21st article? Are you getting the article between 20 and 40? Are you getting only the article you have favorited? It looks like just by saying this, it's going to be a pain to implement using key value only. So it probably means that SQL is going to be your solution to get that. So let's move that out of the way. We know that a list of articles would be a SQL query. Now, if we talk about one article, when you click on the link, well, that's basically the get operation that you see, article/slug. It means that your user will click on the link. The only piece of information you will have on the backend to get the object is going to be the slug. So it looks a lot like a document key. Should it be a document key? What could possibly go wrong if that's the case? Let's think about this. If you have any sense of what could go wrong, please just type it in the chat. And I will try to.
Laurent, I've got. Of course, I've worked with conduits, so I know exactly what could go wrong here. But as we wait for some comments to roll in, I think the first thing that comes to mind for me is, we saw on that screen, there's the ability to edit articles, right?
Yes.
And that includes the ability to change the title. And so if we use the slug as the key in Couchbase anyway, and I think many key value databases, the key is not mutable. You can't change the key. So that is one potential issue. And that might be okay if we can't ever change the key. That might be fine, right? But then we have a situation where the URL doesn't match the title. So that's one thing that came to mind for me. And so comments rolling in. Jeff says key clash could be an issue, right? So I'm thinking if two people want to write an article with the same title, in a site like Medium, that's bound to happen. So how do we deal with that situation?
Yeah, it's a good call. On a relational database, you could probably enforce some sort of uniqueness. Here, we cannot really do that because it's going to be a key clash. We only have one namespace to store articles. That's our collection, and if they have the same key, then it doesn't work. So that means a couple of things. I mean that if you wanted to go through this, you would have to, in your application, each time someone is creating or editing an article and changing the title, you would have to enforce, basically before modifying the document, you would have to look for an existing document with the same key, and you would have to 4-bit this, which would be a little bit complicated. Still doable. Do you want to do this? There's one feature that I like on medium.com, and that's the fact that they have this weird slug, which is a number, and then dash something, 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 and then dash something, something is basically what we would consider as a slug. So they have the unique ID, and then you could put whatever slug you want behind it. It's going to work, which is, I think it's an interesting way of fixing this use case. So, it could work, it could not. Welcome to the world of NoSQL data modeling and data modeling in general. It's all a story of which trade-off you are willing to do. I personally, because it's Couchbase and because we have access to SQL, I'm a little bit lazy. I like to just do UUID for everything. Most of the time, start by this, and then if I have an actually good reason to do otherwise, I will do otherwise. That's how I roll. Now let's talk about comments. A comment, you can add comments, you can delete comments, and you can edit comments. It's pretty straightforward. You will notice the slug again. Like that's what we know. That's how we know which article is being modified. So that's interesting. You know that with the conduit specification, we will always use the slug. It could have been /UUID, but they're going for the slug. So we know that get, put, and delete. A comment is a fairly simple object. It has an ID, creation and update date. It has a body, and it has an author. A new comment is even simpler because you can only comment if you're logged in, so all you have to enter is the body. So what should we do when we want to store articles comment? Should we embed or should we refer? On the left-hand side, you see my article, and here I'm referring to the document. So if you look at the article, might be a little bit tiny, but on the fourth field is comments. It's an array of string. You have two strings that looks like a UUID, and if you look at on the right-hand side, you have two different documents, which document ID matches the string in the array. So what we're doing is we're referring. We are not embedding. We are referring to two existing documents. That's one solution. How do you get to a nice place where it's easy for you to have an article document and have all the comments into the same JSON object? Which is a decent question. With SQL for JSON, with SQL++, which is the SQL we use at Couchbase, it's actually pretty easy to do. If you get your document, here I'm using the ID. It could have been the slug, but here I'm using the ID. You can see a keyword called nest on keys. So let me break that down for you. On the right hand side, what you see is the same article, but with the comments document embedded directly into the article thanks to the SQL query. So they've been stored apart, referred, but you can get them embedded. Select A.star and C as comments. That's your projection. That's what gives you the right-hand side from article A. So from the collection article, and here you see use keys, blah, blah, blah. Use keys is a way to directly access one document if you know its ID. It can also be an array of IDs, but that's one of the things you could do. If you were using the slug, it could have been from article A, nest, comment on keys, blah, 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 where slug equals your slug. Anyway, on the left-hand side of the query, well, I need to stop using left-hand side because it means different things. the result of the first line of our SQL query is going to be the article document as you see here on the left. But I want what we have on the right. I want to take the referred comments and I want to put them directly into the document. That's what you can. That's one of the things you can use with. You can do with Nest. Nest comment C means I'm nesting on another collection called called comments. Sorry, on keys comments. Comments is the name of the field. A is the article collection. So basically, for each keys in the comments array, I'm going to be able to replace them with the actual document, which is why on the right side of the screen you see that the embedded data has a couple fields that we maybe don't really need. If we think about what we had earlier, we just had ID, created that, updated that, body, and author. That should be enough. Here it's a little different. There's an ID field. There's a underscore type field because I'm lazy. I'm using an ORM, so it does a bunch of different things, but it's adding this field. And there's a link back to the article. The article is a UID, and the author is also a UID. If we would have embedded the document, it might have been slightly different, which is these slides that you see here. The embedded version, we don't really have to care too much about this. It's just author, body, created that, updated that. That's all the information you need. So anyway, that's what the nest keyword allows you to do. Can you also nest data with key value instead of SQL? Because if we have only two documents, it's probably going to be faster to use the key value API than running a full SQL query. So if you were to do something like this in Java 20, it will look something like this. The result is exactly the same, but I'm just using code and key value to achieve this. The first two lines are getting the article collection and the comment collection. The first line is getting my article object. I'm creating an empty comment array. And then for each string in the comments field of my article document, that's the for each you see, I'm adding to my empty array the document that I just got from the comment collection. And then I'm putting the nested comments back into my object. So that's one way of doing this. It's very likely going to be faster if you have a small number of comments. And then the question that you might ask yourself is, when you load the page, should you do an infinite scroll? Should you display every comment at the same time? Should you have pagination? Should you only show comments that have been rated? There's no rating here, but that's something you often see on websites. Should you only see the most rated comments and don't display the badly rated comments? If you do something like this, it's going to be SQL. If you have a simple use case, maybe you can, keep using key value. And then, embedding, it's easy. Everything's in there. You can just get it. New question. What could possibly go wrong if you embed the data or refer to that data? My preference is refer because embed scares me because something could go very wrong. And does anybody has the answer? I know, Matthew, you have the answer.
Well, I have some thoughts on this for sure. So I asked people to start thinking about what can go wrong a few slides back because I knew it was coming up. But one of the things with this approach is you really have to think about the business requirements because, depending on what you expect to happen with your comments could very much dictate how you model it, right? So if you imagine a site like Medium, where there's only maybe a few comments for most posts, either of these approaches would probably be okay, but embedding would reduce the amount of performance or amount of latency, I think. But if it's a site like, say, I don't know, Reddit or something that can get a huge amount of comments.
Hacker News.
Hacker News, yeah, sure. Hacker News or any site like that where you can be a large amount of comments. One of the things you're going to run into with embedding is that the document size on NoSQL databases is limited. Not just Couchbase, but all of them. Couchbase has a pretty generous 20 megabyte limit for comments, but you could see a very controversial Hacker News or Reddit post easily go past 20 megabytes. So you really have to think about that. And then one of the things, another approach that you didn't show here was kind of a hybrid approach, is what I did in my implementation, is one document for article and one document for all the comments, right? So that gives you a little bit more headroom in the amount of comments you can leave, but you still have to worry about that 20 megabyte limit. So it's a series of decisions and trade-offs when it comes to how many comments you expect, what's your performance goals, are you going to do pagination? Are you going to do, like you said, infinite scroll? All those things are going to factor into how you model these comments. So here's a comment that just came in. Speaking of comments, embed could be quick for projection, but large data sets could be hard to change. A, and B, more data down the pipe that might not be needed for presentation.
Agreed. Yes, that was my main fear. Infinite explosion of comments. That could happen. Basically, and you probably already, understood that when you're doing data modeling, or when you're doing a conference to teach about data modeling, or webinar, you're probably gonna end up having more questions than answers. That's the whole point of this kind of things. Like what question should you ask yourself is very important. And there's no silver bullet. There's no magical answer. It's everything is straight off, and it's all about not forgetting to ask yourself the right questions.
And I think an important point to bring up is with relational databases, there's typically only one way to do this, right? It would be another table for each comment. It would be one row, and it'd be a foreign key, and it would always be a join, right? Now, sometimes you might be able to get a little clever with JSON and relational databases, but then you have other problems you got to deal with. So what Laurent is saying is a really good point, is that you have a lot of questions, a lot more questions than answers, and therefore you have a lot more flexibility with what you can do.
Which might seem daunting at the beginning, but it's a good thing. All right, so what could go wrong? Lots of things, mostly explosion of the document. Let's move to sign up and, just sign up, actually. I thought it was sign in as well, my bad. Sign up, pretty easy to do. Let's talk about the users. It's you can log in, you can modify a user, you can get the current user, and you can create a user. Pretty straightforward, very different DTOs, but basically you at least need an email and a password, and then a user as several defining characters like biography, an image, and the people that follows the user as well, which you don't see here, which is interesting. Something else that's interesting, when you create a user, you have a username, an email, and a password, but on the login screen, on the login side of things, you have just an email and a password. You're not logging it with your username, and I think that's actually pretty interesting. So let's talk about key design. Yes, when you're logging in, most of the time we would advise you to choose a deterministic ID, like an email, because as a user, if you choose a UUID, I am not going to remember my UUID. I only know my email. So we could use the email as key, and it would do something like this. Select star from user using key, the email. Fine, that's probably going to work. Or getting it straight up from the collection, that works too. You could choose a random ID, and if you have the ID, you can still use keys, but it's not going to work for login. It might work when you are following a user. It might work when you are interacting with another user, because everything happens in the backend and we know the ID. But as a user, I mean, you only know your email, so what you have to do is select star from user where emails equals something, which probably means you would have to have an index on email. But that's something you could do, and you know, it's for key value. Well, I mean, you don't have many solutions. You need to know the UUID, which makes it hard for the login screen. Enter manual secondary indexing, which is a pattern that you will see quite a lot in some key value store, and that we encourage you to use it to a point because it has some trade-offs again. The way it works is, instead of having one document, you have two documents. We still have our document with our random UUID, and we have a document which UUID is the which key, sorry, is the email, and value is the UUID of the user. So that's interesting because we still use the UUID as key for the user, which means we could have any username and any email. We could have several email. We could, like, we don't really care. We could do whatever we want because the unicity constraint is by using the key. But instead, you can get the document, the secondary index document, which is my email address, get the value, which is what the code that you see at the bottom right, have the collection, get the document through the email. It's actually the ID of the document. It doesn't even have to be a JSON doc. It can just be a string. With Couchbase, you don't have to store JSON. You can store anything. If you store JSON, we can do fantastic things. But it can also be just a string. And through that string, I can finally get my actual user. Now that's great because it, you know, we can still be using the UUID, but you can still make it work with a deterministic ID as well. It's just that it's two documents instead of one, which is great because it's going to be fast. It's going to be two key value lookup. It's two key value lookup are still going to be faster than a SQL query. But the thing is, well, you need to maintain those lists because if I remove my email address or change it, then you need to update the document, which is perfectly doable, but we just have to think about this and think about how implementing this is a valuable use of your time, a valuable addition of complexity to your application, than it is better and more efficient at logging in people. I guess UX matter. I guess people want to be logged in fast. But if you only log in once a day, is SQL okay? Probably. Depending on what you do, you know, it's up to you. Profile. The profile is interesting. We've talked about this. I mean, it's pretty straightforward. Again, should you embed or refer? It's not just about the CRUD application, the CRUD side of things, like username, bio, image. It's not very interesting. The interesting thing is the two follow endpoints. You can follow a user, you can unfollow a user. I mean, for it's pretty straightforward, and we've talked about this. It's probably a very bad idea to embed another user because they're going to be modified in different places. So you probably want to refer because also that list could grow indefinitely. I mean, it's going to take you a while until you get that 20 megabytes string list. So it might be very long. Maintaining consistency will be hard. You can always use the nest keyword. That's good too. And is there any screen in Conduit where you would actually display all the users? Probably not. So yeah, I think it's enough. It's just a set that you want to keep as unique as you can, and there's a bunch of things for that on Couchbase. But that's the interesting thing about this is that if you would have used an email instead of a UUID, or username instead of UID, those username and email are not necessarily, like, you can't enforce unicity. So you might have had trouble if people would pick a former username. Can you delete user, or should you delete the document when you delete a user, or should you just archive a user? Does that username become available? A variety of questions that you don't have to ask yourself is because you are using UID. I'm gonna go fast because we don't have that much time left. I'm slow today. Or maybe I've planned for too much. That's probably it. Tags. I think that's the last endpoint I actually want to tell you about. Tags, pretty simple. It's the only endpoint that's available is getting the full list of tags available for every article. There's different ways you can do this. It's probably going to be a SQL query. You can select every tags in an array. You can flatten that array. We have a keyword called ls that allows you to flatten that array, and then you can list. You can have every tags on one namespace. Namespace is what you have after the from clause. You can have every tag on one namespace, and then you can use a distinct word to only get the distinct tags. And also raises some questions about how you add tags. You add tag through the article endpoint, and depending on how you modify the article, you can either replace the full set of tags, why not? Or you can also add, you can use the subdocument API that we have that allow you to only add a unique element in the array, but that's not what I thought it was going to do, because it only enforces unicity in one set of tags, not in the whole database, so that doesn't even work. It's going to be complicated to actually get unique tags completely. So I think that's one of the shortcomings of the Conduit API. You should probably have a tag service that doesn't only return tags, but also care about unicity. I think that's something to enhance. I don't have much time left. Where we are at favorites. I mean, favorites probably the same questions than the user. Maintaining consistency is a challenge because you are favoriting different article. If you embed, then it's unlikely that you want to embed the full article, especially if it's big, because you're going to hit that 20 megabytes limit much faster. The list can go indefinitely. You can nest the data. You know the drill. Before we go to the summary, there's one quick thing I'd like to show you, which is an actual example. Moving things fast, I'm going to run something called Hotel Desktop Viewer, which is open. It stands for Open Telemetry Desktop Viewer, and it's going to allow me to, once it goes into the right screen, record Open Telemetry traces. Open Telemetry is a standard to record metrics, logging, etc., and traces. I have a unit test that does a variety of things, but mostly what it does is cleaning up a bunch of things, creating a new user document. It retrieves the user document using my object document mapper, which is Spring Data in that case, by running a query, an automatically creating query. So we're going to see how much time does it take. It also tries something different. It's also insert that secondary index I told you about. It's just a simple document that has the email as key and the UUID as value. And then I'm running find by email with key value, which is basically doing getting the simple lookup document with the email, and then getting the ID, and then getting the doc. So we'll see how fast this is. So let's go. Let's run this thing. Whoop. this should, in all likelihood, start recording traces here at some point. So here we are, the tests are running. While this is running, you can see on the right hand side, I have the Couchbase plugin. It allowed me to browse my Couchbase databases, and you can see, for instance, that document, which is the email and the UUID, and then the actual UUID, which is the actual content, which is cool. You can also run queries on this, which is quite nice. So let me select a scope, and let me go back to another query. I think I had the yes, this one. Hopefully it's the right bucket. Oops. And I just ran the query. I just got the result, which is quite nice. You can see the result of my nest comment. You can ask for advice. There's no secondary index recommended at this time because, well, I'm using the key. If I just remove this and use where ID equals or where emails equals, then it probably, allow me to give me an advice for another index. So here we are. My OpenTelemetry desktop viewer has recorded a bunch of stuff. Let's go at the top. Here's a query. This is a SQL query. It took 286 milliseconds. And this is the actual query. It selects the whole projection, every field of my objects, where emails equals something. So that was defined by email from the user collection. Okay, 286 milliseconds. And here you can see I have two gets. I have the get with the email, took 94 milliseconds. And I have another get, which is the actual UUID that gets me my object. So I'm what, 200 milliseconds instead of 300 roughly. Knowing that I am currently in Paris and the data center is in probably US East 1, so the bulk of my current latency is from my connection to go to my data center and then come back from my laptop. But the order of magnitude is interesting. Yeah, I can, even with a very bad latency, I can do 2 key value instead of 1 SQL query. If your application has a very short latency because it's situated very close to your database, then it's even bigger. It's even better. Because 100 milliseconds is probably my current latency, probably 80. So if you remove 80 from each operation, that means 200 milliseconds left for the SQL query and like 5 milliseconds left for the key value, which is still like quite impressive. Imagine the number of key value operation you can do instead of doing SQL query. So we really encourage you to do key value when you can, because it is so much faster. I think we are almost about time. So let me go back to summary and Q&A quickly. Basically, a couple of things you need to do. Analyze your domain, make sure you know which field you need to store and where. That's the first step. It's where you can ask yourself about the embed and referring side of things. And the other is try to match your query hard pass. What are the queries you're going to do the most? What are the ways you're going to get the data the most? Try to map it with your domain and how you define, and it's going to basically allow you to work on your key definition, your key strategy, and your embed or referral strategy. Next steps quickly. Cloud.couchbase.com, 30 days free trial, no credit card required. You're more than welcome to try Couchbase Capella. You have a query workbench. You can do everything I showed you in the ID. You can probably do as well on Capella. You can list you have the whole workbench. You can run the query you want. You have Couchbase IQ, which is our kind of a copilot AI assistant that allow you to, that's going to help you generate queries for you. It's going to help you generate sample data. On the ID, it can also help you to write code. It's pretty cool. A couple links, the JSON data modeling guide and data modeling phases. And of course, the IntelliJ plugin available on, well, it's not just IntelliJ, it should be JetBrains plugin, so it's available on every JetBrains ID. If you're using PyCharm, ID, Rust Rover, whichever they support, it's going to be available. Thank you so much. I see Suzanne just came back. It's 7 p.m. God, do we have time for questions? Do we have questions?
If any more questions, we can go a couple minutes over.
So, Laurent, there's a question I wanted to bring up while everyone else is maybe thinking and typing in their question. So you kind of showed the performance difference between a SQL query and a simple key value lookup. You also described some more complex key value lookup situations where you're basically creating an index manually and managing that yourself. So I guess my question is, performance is important, yes, but maintainability, developer productivity, bug fixing, causing new bugs, those are also important considerations. So, how complex would you switch from a complex series of key value operations to a very simple and readable SQL query? What's kind of the trade-off for you there?
I mean, if you're asking for trade-offs, you're asking for more questions. I guess it depends a lot on your architecture as well. It's a debate I've had with GraphQL fans for quite a while. You can think of GraphQL as a universal ORM, and should it be attacking your database trade-off? Probably not. You should have probably some middleware, and that middleware will allow you to do a lot of business decision. There needs to be a lot of calculation, computation changes that needs to be done that you cannot do straight in the database there. And I think that's also true for any ORM or ODM or any lightweight way of accessing a database. Usually you have a small layer of middleware that sits on top. If you have that layer of middleware that sits on top, it's going to be easier for you to do lots of constraint implementation, lots of manual secondary indexing, all that stuff. If you don't, that is going to be really hard because everybody's going to go through your database directly, and then you won't have any chances of enforcing those rules. So you are probably going to have to stick with SQL because there's so much more you can do with SQL. One could make the point that if you have all those middleware layer, then you probably have more complicated enterprise needs, and you probably have needs to be more optimized, and so probably also have the amount of developers and workforce and money to implement all of that. So I guess it mostly depends on that as well. What kind of company are you? Where are you on your journey? And how many developers do you have available?
Yeah, it's we think about modeling as a technical issue, but it's very much a business issue, organizational issue, and trade-offs issue. So, any recommendations or comments about blob storage?
Blob storage? You mean binary?
I think so. So Jeff has been asking about images and videos. He's been asking about archival use cases. So
okay,
yeah.
You should probably never ever store any binaries in any database because that's not the you don't want to do that. The reason you're using a database is to have a way to query data based on, actually maybe AI is going to change that. So scratch that. What you want to do is get some structured or unstructured data with your query language. Usually with binaries, all you have to query that binary is an ID. It looks like a key value store, so it looks like a good use case for key value, but really the important thing about database is you want to be fast, you want to be operational, because you want to get that data out fast. For an image or a video or sound, the real-timeness of that data and the complexity of that querying doesn't justify putting this into a database. It should just be and object storage. Every object storage are S3 compatible these days. So, depending on where you are, what is your cloud of choice? If you're on-prem, there's also a lot of things that emulate S3. So I would aim at using an S3 compatible solution. And what you can store in the database is the S3 address of your document. That's also what we use for attachments, if I'm not mistaken. It's something we can use for attachments on Couchbase Mobile, if I remember correctly.
And then also keep in mind that Couchbase is distributed. So if you have replicas of data, that means if you're uploading a large binary, it's got to be replicated across the whole cluster, which can be, that can be a real bottleneck. So it may not be the best choice for binaries. We do have customers who store binaries in Couchbase, but, basically you need to really know what you're doing. And that 20 megabyte limit still applies. So maybe one more question here. Is that okay, Suzanne? We got time for one more? I don't know if Suzanne can hear me, but I'm going to go ahead and ask the question.
Yes.
So someone's asking for middleware recommendations.
That is a question for even more questions. So most middleware are you're basically asking us for an architecture advice. It depends on your language. It depends on the database you're using. It depends on the amount of database you're using, because many people use many databases. Couchbase users use Couchbase because we do a lot of different use cases at the same time, which is one of the reasons people choose Couchbase. I just got informed, and that's very new, that Autoroshi supports Couchbase, because I just got a DM from the main developer right before starting that webinar. Autoroshi is a reverse proxy. It's kind of a business mesh API gateway kind of thing. It's a great middleware layer that's powering up the internal developer platform of Maif, which is one of the biggest insurance company in France. And it's not official yet because it just ended up in my mailbox, but apparently they support Couchbase now, which is great. I use Spring Data a lot because I'm a Java developer, but if you're not a Java developer, don't go there. There's no good or bad answer. It really depends on who's working with you. Do you have the money to actually buy an not open source middleware, but that most of them are open source these days? It's a very open-ended question, and really depends on who you're working with. Are they junior? Are they senior? Do you have a lot of them? Is this only you? Should you be using a ready-made internal developer platform? Should you be using Kubernetes and start building everything on top of Kubernetes? Who knows? Depends. So many questions.
Laurent, could you spell that Autoroshi or whatever it was you said?
I'm going to send you a link.
Okay. I think we can end it there, Suzanne. That's okay with you.
Yeah. So, hey, thanks everybody for hanging out just a little bit longer. We still have some folks on. Appreciate all the great questions, all the great content, Laurent. Obviously, a lot to discuss around data modeling. So we could probably do another session with more. So for now, just everybody know that you're going to receive a follow-up email with the on-demand version of this webcast. Please feel free to share that with your teams or anybody else who might be interested. I will also add the links that Laurent shared in his presentation in that docs section. So there's a few things there already. Check that out before you log out. Otherwise, you'll have access to those docs again. And I'll include the additional links to the trial and the IntelliJ JetBrains plugin and some of the other things that Laurent shared today. So look out for that. And if you have any questions at all, you can reach out to me. I actually stuck my email in there, suzanne.loftus@couchbase.com. I'm happy to get any more information out to you. So thanks again for joining us. Have a great day, everybody, and hopefully we'll see you again very soon. Take care.
Thank you.